In 2023, a single subatomic particle slammed into Earth, carrying an amount of energy that, according to everything we know about physics, should not have been possible. Not rare, not extreme, actually impossible, based on every known source of high-energy particles anywhere in the observable universe. Scientists studied it, checked their instruments, and confirmed it was real. And then, for years, nobody could explain where it came from. Now, a team of physicists thinks they finally have an answer, and if they're right, it doesn't just solve one mystery. It might be the first real evidence of something Stephen Hawking predicted exactly 50 years ago. Evidence that a black hole, somewhere out in the universe, actually exploded. I'm Your Name, and this is your channel. If physics mysteries this strange are why you're here, subscribe now, because this one connects half a century of theory to a single real event. Let's start with the particle itself, because the numbers here are genuinely hard to wrap your head around. In 2023, a network of detectors called KM3 NEAT, buried deep in the Mediterranean Sea specifically to catch these kinds of events, registered an ultra-high energy neutrino, a nearly massless particle that can pass through almost anything, including entire planets, without interacting. Neutrinos are famously hard to detect precisely because they barely interact with matter at all, which is exactly why burying a detector deep underwater, waiting patiently for the rare one that does interact, is how you catch them. This particular neutrino carried roughly 100,000 times more energy than the most powerful particle ever produced by the Large Hadron Collider, the most powerful particle accelerator humanity has ever built. To put that in perspective, the Large Hadron Collider is a 17-mile ring of superconducting magnets that took a decade to build specifically to push particles to the highest energies physics allows us to produce artificially. And this single, naturally occurring particle blew past that benchmark by a factor of 100,000. Here's the actual problem. What if physicists have a well-established list of cosmic events capable of producing extremely high-energy particles? Things like supernova explosions, active galactic nuclei, gamma-ray bursts. When researchers checked this neutrino's energy against every known source on that list, none of them worked. Nothing we currently understand about the universe is capable of producing a particle with this much energy. It was, by every conventional measure, impossible. For a while, that's exactly where the story sat. A real, confirmed, measured particle, with no explanation for where it came from. Then, in February of 2026, a team of physicists at the University of Massachusetts Amherst, Michael Baker, Joaquim Iguaz-Juan, Aidan Simons, and Andrea Tam, published a paper in Physical Review Letters, proposing something genuinely wild. This impossible neutrino might be the first observed evidence of an exploding primordial black hole. To understand why that's such a significant claim, you have to go back to 1974 when Stephen Hawking made one of the most famous predictions in modern physics. Black holes, Hawking argued, are not actually completely black. Due to quantum effects happening right at their boundary, black holes should slowly emit particles over time, a process now called Hawking radiation. And here's the key detail. The smaller and lighter a black hole is, the hotter it becomes, and the faster it radiates away its mass. As it loses mass, it gets even lighter and therefore even hotter, radiating even faster. A runaway process that, for a small enough black hole, should eventually end in a final, dramatic explosion, releasing a burst of particles as its very last act. The problem is, for ordinary black holes, the kind formed when massive stars collapse, this process is almost unimaginably slow. Even the smallest stellar mass black holes would take roughly 10 to the power of 67 years to fully evaporate, a number so much larger than the current age of the universe that it might as well be infinite. In other words, no black hole formed from a dying star has had anywhere near enough time to actually reach the explosive end of this process. If Hawking radiation is real, and virtually all physicists believe it is, we should never actually be able to observe the final explosion from any black hole that exists today, unless the black hole in question isn't a normal one. This is where a different, more exotic idea comes in: primordial black holes. Unlike black holes formed from collapsing stars, primordial black holes are hypothesized to have formed in the extreme, chaotic conditions of the universe's earliest moments, right after the Big Bang, potentially forming with masses far smaller than any stellar black hole ever could. A primordial black hole, small and light. Enough could, in principle, have already had enough time since the beginning of the universe to evaporate down to the final explosive stage of its life, right around now. But even this idea ran into trouble. Standard models suggested that primordial black holes light enough to be exploding today should already have been ruled out or strongly constrained by decades of astronomical observations, making a direct detection seem implausible. This is exactly the gap the UMass Amherst team's new research tries to fill. Their proposal introduces something they call a dark charge. The idea that some primordial black holes might carry a type of electric charge under a hypothetical dark force, essentially invisible to all of our normal detection methods, but still governed by real physical rules. According to their model, a primordial black hole carrying this dark charge could become what they call quasi-extremal, or meaning it holds close to the maximum charge physically possible relative to its mass. That specific condition would cause the black hole's evaporation to slow down dramatically, allowing it to survive far longer than an ordinary uncharged black hole of the same size would. Long enough, potentially, to have survived all the way from the early universe until now, only to finally discharge and complete its final Hawking radiation-driven explosion in the present day. If that model is correct, it would neatly explain why we haven't already ruled out primordial black holes from existing today, and it opens the door to the idea that an explosion like this really could be happening somewhere in the universe right now, potentially producing exactly the kind of impossibly high-energy particle that hit Earth in 2023. There's one more detail that makes this proposed explanation particularly compelling. It also helps resolve a smaller mystery within the mystery. A separate neutrino detector called IceCube, buried in the ice at the South Pole, didn't detect the same impossibly energetic event that KM3NT caught. If the neutrino simply came from a distant, ordinary astrophysical source, you'd generally expect both major detectors to have at least some chance of catching a signal like this, but the specific physics of an exploding quasi-extremal primordial black hole, according to the researchers' model, naturally explains why one detector could register the event while the other didn't, adding a layer of internal consistency to the theory that a more conventional explanation doesn't provide. Now, here's why physicists are genuinely excited about this, beyond just explaining one strange particle. If scientists could directly confirm an exploding primordial black hole, it would represent not one, but potentially three separate massive breakthroughs at once. First, it would be the first direct evidence that primordial black holes actually exist at all, something that's been theorized for decades, but never confirmed. Second, it would be the first direct experimental verification of Hawking radiation itself, a 50-year-old theoretical prediction that has never once been directly observed, despite being one of the most famous ideas in modern physics. And third, because a black hole's final explosion should release every type of fundamental particle that exists in nature, not just the ones we already know about, like electrons, quarks, and Higgs bosons, but potentially entirely new particles we've never detected before, including candidates for dark matter, catching one of these events. Could hand physicists a complete inventory of the particles that make up reality all at once in a single burst? According to the researchers' own calculations, if their model is correct, a primordial black hole explosion of this kind could realistically be happening roughly once every decade, frequently enough that with the right detectors watching in the right way, we might actually be able to catch the next one on purpose, rather than stumbling into evidence of it years after the fact. To be clear about where this stands scientifically, this is not confirmed. Nobody is claiming with certainty that the 2023 neutrino was definitely produced by an exploding black hole. It's a serious, peer-reviewed hypothesis, published by credible researchers, that fits the strange data better than any other explanation currently on the table. But it remains a hypothesis, and testing it further will require more data, more detections, and more scrutiny from the broader physics community before anyone can call it confirmed. But think about what's actually being proposed here. A single particle, born from a source unlike anything else in the known universe, might be the very last flicker of light from a black hole that formed in the earliest moments after the Big Bang, survived for over 13 billion years, and finally, sometime before 2023, reached the true end of its existence, exploding in a final burst that Stephen Hawking described, in theory, half a century before anyone had the instruments capable of possibly catching it happening. If that connection holds up, we may already be sitting on the very first piece of physical evidence for one of the most important, unconfirmed predictions in all of modern physics. One that's been waiting quietly since 1974 for exactly this kind of impossible particle to finally show up. If you want to know whether scientists catch the next one, subscribe and turn on notifications, because we'll be covering it the moment new evidence comes in. Drop a comment with what you think this particle actually was, and share this with someone who thinks physics stopped making new discoveries decades ago, because right now, a 50-year-old prediction from Stephen Hawking might finally be getting tested by a single particle that hit Earth in 2023.